So today let's discuss questions related to asymptotes and curve tracing. So there were only 5 to 6 questions asked on this topic. So let's see them one by one. So the question 1 says that how many loops are generated for the curve r equals to a sine theta. So we have a curve r equals to a sine 3 theta, and we're supposed to find how many loops are there in this curve, and further it asked us to find the sum of the area of all the loops. So there is a formula, like if my curve is r equals to a sine n theta, then number of loops are, so basically number of loops depend on this n. So if my n is odd, then number of loops are n, and if n is even, then number of loops are 2n. So since in our case n is equals to 3, so there are 3 loops. So our curve basically r equals to a sine 3 theta is a 3 petal rose. Now let's draw the curve of this given equation, and let's find the area. So the given equation to me is r equals to a sine 3 theta. So if I put r equals to 0, so from here I'll be getting a into sine 3 theta equals to 0. So that basically gives me sine 3 theta equals to 0. So from here I got my 3 theta is equals to n pi, and here n belongs to integers. So from here I got my theta as n pi by 3. Now I can vary value of n to see at what value in between 0 to 2 pi my r approaches 0. So if my n is equals to 0, then theta is 0, and if n is equals to 1, my theta is pi by 3. So my first loop of curve lies in between 0 to pi by 3. Likewise, I can check where my second and third loop lies. So when n is equals to 2, theta is 2 pi by 3, and when n is equals to 3, theta is pi. So a second loop lies between 2 pi by 3 to pi. Likewise, when my n is 4, theta is 4 pi by 3, and when n is equals to 5, my theta is 5 pi by 3. So from here I can say that my third loop lies in between 4 pi by 3 and 5 pi by 3. So now let's just plot the graph, and then we'll find the area. So this is my y-axis. So theta equals to 0 lies here. Theta equals to pi by 3. So these are the lines in between theta passes. So our first loop will be something like this, our second loop will be something like this, and our third loop will be basically something like this. So this is my curve. This is curve r equals to a sine 3 theta. Now I am supposed to find the sum of area of all the loops. So all these loops are basically equal in area, so it's enough to find area of one loop, and then we can multiply it by 3. So this is the area, that is the shaded area which we are supposed to find. So area of this first loop, area of loop in between theta equals to 0 to theta equals to pi by 3. We know that formula of area for a polar equation is basically 1 by 2 into theta 1 to theta 2 r square d theta. Now I can substitute just value of theta 1 and theta 2 and r, and I can solve accordingly. So it will be 1 by 2, 0 to pi by 3. My r is a sine theta, so it will be a sine 3 theta square into d theta. So this thing is equivalent to 1 by 2 into 0 to pi by 3 a square into sine square 3 theta d theta. A square is constant, so I can take it outside the integral sign. So I'll be getting a square by 2 0 to pi by 3 into sine square 3 theta d theta. So now I can multiply and divide by 2 so that I can get rid of this whole square thing. So it will be basically equal to this, and we know that 2 sine square theta is equals to 1 minus cos 2 theta. So using this relation, I'll be getting 2 sine square 3 theta equals to 1 minus cos 6 theta. So this thing will be equals to a square by 4 0 to pi by 3 1 minus cos 6 theta d theta. Now if I solve the integration, I'll be getting a square by 4 theta minus sine 6 theta by 6 0 to pi by 3. So this will be equal to a square by 4 into pi by 3 minus 0 minus 1 by 6 into sine 6 pi by 3 minus sine 0. So this thing will be equal to a square by 4 into pi by 3 minus 1 by 6 into this will be sine 2 pi. Sine 2 pi is 0 and sine 0 is 0, so this will be 0. So area of first loop is a square pi by 12. But we know that these three loops are same in area, so we can just multiply by 3 to find sum of area of loop. So sum of area of all the loops is equals to 3 into area of first loop, that is a square into pi by 12. So we got the required area as a square pi by 4. So this is the first part of question. Let's see what we're supposed to find in second part. So in second part, we're supposed to find the asymptote of this curve r into log e theta is equals to a. So in second part, we're supposed to find asymptotes of r into log e theta equals to a. So to find asymptote of this curve, first we'll substitute r is equals to 1 by u. So if I do that, I'll be getting 1 by u into log e theta is equals to a. Now I can explicitly solve it for u. So I'll be getting u is equals to 1 by a into log e theta. Now I need to check the value of u for which value of theta for which u approaches 0. So if u approaches 0, I'll be getting 1 by a into log e theta is equals to 0. So from here I can say that my log e theta must approach to 0. So we know that if theta approaches 0, then my log e theta is log e theta approaches 0. Sorry, my bad. Theta will be basically approaching 1, because if this is equals to 0, I can write it as log e theta is equals to e raised 0. So from here I'll be getting theta is equals to e raised 0, that is 1. So for theta equals to 1, this approaches 0. Now I got my theta as 1. Let's name it as theta 1. So I got my theta 1 as 0. Now if I find du by d theta, I'll be getting 1 by a into theta, 1 by a theta basically. So my p will be basically limit theta approaches theta 1, that is 1, minus d theta upon du. So this is equals to limit theta approaches 1 minus d theta upon du, that is a theta. So this is equals to minus a. Now we know that p must be equals to r sine theta 1 minus theta, and this theta basically gives us the value of asymptote. So from here I'll be getting p, that is minus a, equals to r sine theta 1, that is 1 minus theta. So from here I'll be getting a equals to r sine theta minus 1, that basically gives me sine theta minus 1 equals to a by r, or theta minus 1 equals to sine inverse a by r. So from here I got my theta as 1 plus sine inverse a by r. So now let's move on to next question. So in the next question we are supposed to trace this curve. So the given curve is y square into x square minus 1 is equals to 2x minus 1. So we'll like if we go ahead with plotting this curve by taking arbitrary points and then as x and then checking its value, then it will be too complicated because it's not a simple curve. So what we'll do is we'll see the certain basic properties like symmetricity, or maybe the basic points from where it is passing on x-axis or on y-axis, and then the asymptotes of it. So if you see that it is symmetric about y-axis, it's symmetric about x-axis, because because this curve is same. This gives me same equation when I put y equals to minus y, that is minus y square x square minus 1 is equals to 2x minus 1. So this is same as writing y square into x square minus 1 equals to 2x minus 1. So this is the first thing that I got, that it is symmetric about x-axis, but it is not symmetric about y-axis. Not symmetric about y-axis, because if I name my function fx as y square x square minus 1 minus 2x minus 1, then f of minus x doesn't give me the same thing. So this is my second result. My third result will be, you can observe that if I put a 0, x equals to 0 and y equals to 0, then the equation doesn't satisfy itself. So from here we can say that our curve doesn't pass via origin. Now let us check at what point it intersects x-axis and y-axis. So if it is intersecting y-axis, then on that x is equals to 0. So if I put x equals to 0, I'll be getting y square into minus 1 is equals to minus 1. So from here I got y equals to plus minus 1. So at 0, 1 and 0, minus 1, our curve is intersecting y-axis. Now let's check about the points where it intersects x-axis. So we know that on x-axis our y is equals to 0. So if in the given curve I put y equals to 0, I'll be getting 0 equals to 2x minus 1. So from here I got my x as 1 by 2. So at 1 by 2, 0, curve is intersecting x-axis. Now let us check asymptotes of the given curve parallel to y-axis and x-axis. So asymptotes parallel to y-axis will be so basically what we'll do is we'll compare the coefficient of highest power of y with equals to 0. So if you observe that highest power of y is 2, so the coefficient of y square is basically x square minus 1. So x square minus 1 equals to 0 gives us basically the asymptotes that are parallel to y-axis, that is basically x equals to plus minus 1. So these are basically asymptotes parallel to y-axis. Now let us find out asymptotes that are parallel to x-axis. Asymptotes parallel to x-axis. So for that what we'll do is we'll compare the highest degree over x with equals to 0. So that is basically gives me y square equals to 0. So from here I got y square equals to 0, which basically gives me y equals to 0 as asymptote parallel to x-axis, that is x-axis itself. Now if you see that like what I can do is I can explicitly express y in terms of x and then see where the value of y lies in between the y lies in the curve. So my y square will be basically 2x minus 1 divided by x square minus 1. So y square is equals to 2x minus 1 divided by x square minus 1. But we know that y square is always greater than or equals to 0. So from here I'll be getting 2x minus 1 should be divided by x square minus 1 should be always greater than 0. So from here if you see that I'll be getting x in between minus 1 to 1 by 2 union greater than 1. Yeah, 1 to infinity at 1 by 2. 1 to infinity. You can check this using by plotting the point of discontinuities like minus 1, 1 by 2 and 1, and then you can check the sign of this function, like whether here it's positive and negative, and you'll find out that in between minus 1 by 2 and here, like if I take point as 0, so I'll be getting something positive, but if I take x as minus 2, so it will be negative here. Likewise it will be negative here, like you can take point as 0.8 maybe, so again here it will be negative, and here if you take point greater than 1, then also you'll be getting positive. So this is basically positive when x belongs to this. Also if you observe that if I find, like from here I can say that my y will be basically plus minus under root 2x minus 1 divided by x square minus 1. So when x approaches either plus or minus 1, basically my y approaches plus and minus infinity. So this thing we can conclude from the asymptote things as well. Also, if I find dy by dx from here, so that will be basically plus minus 2x minus 1 divided by x square minus 1 minus 1 by 2 into derivative of that will be x square minus 1 into 2 minus 2x minus 1 into 2x divided by x square minus 1 whole square. So this thing is equal to, I'm simplifying just this term, so it will be this multiplied by 2x square minus 2 minus 4x square plus 2x divided by x square minus 1 whole square. So this is equals to 2x minus 2 minus 2x square divided by x square minus 1 square into this term. So it will be x square minus 1 divided by 2x minus 1 raised 1 by 2. So you can see that my dy by dx approaches infinity as x approaches 1 by 2. So from here we can say that our graph has basically a tangent along this x equals to 1 by 2. So using this information, also if you see that from here you can observe that our curve doesn't lie in between 1 by 2 to 1. So using the information that I have derived, so if this is my y-axis, this is my x-axis, we have asymptotes at x equals to 1 and x equals to minus 1. So this is basically x equals to 1 and x equals to minus 1. Also the curve is intersecting x-axis at 1 by 2 comma 0 and y-axis at 0 comma 1 and 0 comma minus 1. Further we have a tangent sort of thing here at x equals to 1 by 2. If this is the asymptote, then our curve will be somewhat like this here. Likewise because we have symmetricity about x-axis, so here also our curve will be something like this. And because we cannot join it with a straight line here, because you see our curve is basically of degree 2, so it will be somewhat like this passing from here, and we have a tangent sort of thing here as well at x equals to 1 by 2. Likewise x equals to 1 is also a tangent to my curve, also asymptote to my curve. So as x approaches 1, so this thing also be here also I'll get a graph, because we have no curve in between 1 by 2 to 1 comma 0, so we cannot make it like this. So this we cannot do, so we'll have a curve like this, and since it is symmetric about x-axis, so in the fourth quadrant also we'll get a curve like this. So this is basically the rough sketch of the curve that we are given. So let's move on to next question. So in the next question also we are supposed to basically trace the curve, and here a is a real constant. So the curve given to us is y square into x square is equals to x square minus a square. So first thing you can observe that it is symmetric along both x-axis and y-axis. Curve is symmetric along both x-axis and y-axis. You can check that by substituting y with minus y. If you get the same curve, then it is symmetric about x-axis, and if you substitute x with minus x, then it is, if you get the same curve only, then it is symmetric about y-axis. So that you can check. So second thing what we can say is, if I put both x equals to 0 and y equals to 0, that is if x equals to 0, y equals to 0, I get 0 equals to minus a square. But that doesn't, that basically shows that our curve doesn't pass via origin. Now if I express my, first let's find out asymptotes. Asymptotes parallel to y-axis. So that I'll be getting by comparing the coefficient of y square with equals to 0. That basically gives me x square equals to 0. So from here I got my x is equals to 0. That is basically y-axis only. Likewise, if I find asymptote parallel to x-axis, so for that I need to compare coefficient of x square with equals to 0. So from here my equation of curve is basically y square x square is equals to x square minus a square. So I can write it as a square is equals to x square minus y square x square. That basically gives me a square equals to, I can take x square as common, so I'll be getting 1 minus y square. So my coefficient of x square is basically 1 minus y square. So if I compare it with 0, so I get y is equals to plus minus 1. So asymptotes parallel to x-axis are basically plus and minus 1. Now let's check other behavior, like where it intersects x-axis and y-axis. So curve intersects x-axis at, so if I put y equals to 0, I'll be getting x square minus a square equals to 0. So it basically gives me x equals to plus minus a. So my curve intersects x-axis at a comma 0 and minus a comma 0. Also my curve intersects y-axis at, so for that I need to put x equals to 0, but if I put x equals to 0, I get basically 0 equals to minus a square. So that is an absurd result. So from here I can say that my curve doesn't intersect y-axis. Further, so basically this is my curve y square into x square is equals to x square minus a square. So what I can do is I can explicitly express the curve in terms of both x and y and see where the values of x and y lies. So if I write it as y square equals to x square minus a square by x square. So from, we know that our y square is always greater than equals to 0. So from here I can say that my x square minus a square should be greater than equals to 0 because x square is already greater than 0. So from here I got my x minus a into x plus a as greater than equals to 0. So this basically gives me that x lies in between minus infinity to minus a union a to infinity. So this is basically where our x lies, value, like these are the values that our curve can take for x. Likewise, if I express explicitly it in terms of x, so I'll be getting a square is equals to x square into 1 minus y square. So from here I get my x square as a square divided by 1 minus y square. So x square is also greater than 0. So from here I got, for that to be greater than 0, 1 minus y square should be greater than 0, greater than equals to 0, because Like we can ignore 0 also, because y equals to plus and minus 1 are acting as asymptotes only. So if that's the case, my y must lie in between open interval -1 to 1, because at y equals to plus and minus 1, the curve has an asymptote and it approaches infinity. So this, like here in between my curve lies. Now let's just try to plot our curve. So this is my y-axis, this is my x-axis, and parallel to x-axis we have asymptotes at y equals to 1 and -1. This is line for y equals to 1, and let's say this is line for y equals to -1. Further, our curve intersects x-axis at a comma 0 and minus a comma 0. So let us assume that this is a comma 0 and this is point minus a comma 0. So also it is symmetric along both x-axis and y-axis, and our curve is taking x values of x from here to here and here to here, and y in between 1 to -1, and at y equals to 1 and -1 we have asymptote. So in first quadrant our curve will be somewhat like this. Likewise, since it is symmetric along about the x-axis, so in fourth quadrant our curve will be somewhat like this. But we have concluded that our curve is also symmetric about y-axis, so the mirror image along the y-axis will be the curve in second and third quadrant. So that will basically give this as graph of our curve. So basically this is the required graph that we are supposed to plot. So now let's move on to next question. So the next question says that find all the asymptotes of this curve. So the curve given to us is 2x plus 3 into y is equals to x minus 1 square. So from here I got, if I simplify it, I'll be getting 2x plus 3 into y is equals to x square plus 1 minus 2x. So that basically gives me x square plus 1 minus 2x minus 2xy minus 3y equals to 0. So my curve is basically x square minus 2xy minus 2x minus 3y plus 1 equals to 0. So I can, first thing that we do is we check if we got any asymptote parallel to x-axis or y-axis. So for that we basically compare the highest term with highest coefficient of x equals to 0, and likewise for y. So x square is the highest degree term involving x, only x. So from here if I compare it with 0, I'll be getting 1 equals to 0, but that is a absurd result. So we don't have any curve basically that is parallel to x-axis. No asymptote parallel to x-axis. Now if we want to find asymptote parallel to y-axis, so for that we need to compare the coefficient of y with equals to 0, because there is no term involving y square. So if we do that, so we'll be getting 2x plus 3 equals to 0. So from here I got x equals to minus 3 by 2. So x equals to minus 3 by 2 acts as asymptote parallel to y-axis. Now to calculate other asymptotes, what we'll do is we'll substitute y equals to m and x equals to 1 for other asymptotes. So if we do so, we'll be getting 1 minus 2m minus 2 minus 3m plus 1 equals to 0. So if we solve it, what we do is basically we calculate a function phi, nm, where n is basically the combined degree. Like if this is my a0 plus a1x plus a2y plus a3, let's say xy, plus a4x square plus a5y square. So we basically calculate 5 to m, and phi to m is basically in those terms which have combined power as 2, like in this term and this term and this term. So I'll be putting y equals to m and x equals to 1. So what I'll get is m square a5 plus a4 plus a3m. So that's how I calculate phi 2 of m. Likewise, phi 1 of m will be basically, in these two terms I'll be putting y equals to m and x equals to 1. So that gives me basically a1 plus a2m. So using this, if I calculate phi 2m, so phi 2m will be basically 1 minus 2m. Likewise, phi 1m will be basically equals to minus 2 minus 3m. So we just compare the highest n phi 2m here with equals to 0. So if I equate phi 2m with equals to 0, I'll be getting 1 minus 2m equals to 0. So from here I got m equals to 1 by 2. That is basically the slope of the asymptote. Asymptote is basically a straight line, so that will be of form y equals to mx plus c. So from here I got my m as 1 by 2, and I just need to find out the value of c. So there are two methods to find value of c depending upon the value of m we get. Like if they are distinct m's, then we have different method, and if we have same value of m, then we have different method to find the value of c. So here, since we have only one m, so we can use any of the methods. So if I use, so my c will be basically equals to minus of phi 1m divided by derivative of phi 2m, and here my m is basically 1 by 2. So if I solve it, I'll be getting c into minus of phi 1m, that is minus 2 minus 3m, divided by derivative of phi 2m, that will be basically minus 2, and we are calculating at m equals to 1 by 2. So my c is basically 2 plus 3 into 1 by 2 divided by minus 2. So this basically gives me 4 plus 3, 7 by 4, and there is minus sign also. So my c is basically minus 7 by 4. Thus my required asymptote is y equals to, my m is 1 by 2 into x plus c, that is minus 7 by 4. So for the given curve, we have two asymptotes. One is at x equals to minus 3 by 2. First asymptotes are x equals to minus 3 by 2 and y equals to x by 2 minus 7 by 4. So these are the two asymptotes to the given curve. So let's see the next question. So the next question says that find the asymptote of this curve. So the given curve is basically x cube plus 3x square y minus 4y cube minus x plus y plus 3 equals to 0. So first thing that we do is we'll check if there is any asymptote parallel to x-axis and y-axis. So the highest coefficient of term involving x is only this. So if I equate coefficient of this with 0, so I'll be getting 1 equals to 0. So from here, likewise, if I equate coefficient of highest term of that is y cube with equals to 0, so that basically gives you minus 4 equals to 0. So from here I can say that curve has no asymptote parallel to x-axis and y-axis. Now let us just find f3, f2 and f1 because highest term is 3. Sorry, phi 3, phi 2 and phi 1. So my phi 3m will be basically, like in the 3 degree terms, I'll be putting x equals to 1 and y equals to m. So this gives me 1 plus 3m minus 4m cube. Likewise, my phi 2m will be basically, there is no term with degree 2, so phi 2m is 0 and phi 1m is basically minus 1 plus m. So I find value of m and we calculate by substituting phi 3m equals to 0. So that basically gives me 1 plus 3m minus 4m cube equals to 0. So from here, if I solve it for m, you can, by hidden trial, you can see that m equals to 1 is a root. So m equals to 1, and if I divide it by m minus 1, so I'll be getting 4m cube minus 3m minus 1. So if I divide the 4m square, so 4m cube minus 4m square minus plus 4m square minus 3m minus 1 plus 4m square minus 4m. Again if I subtract, so I'll be getting m minus 1, so plus 1. So this term I can write it as 4m square plus 4m plus 1 into m minus 1 equals to 0. So, and this term is basically equals to 2m plus 1 square into m minus 1 equals to 0. So from here I got my m as minus 1 by 2, minus 1 by 2 and 1. So if you see that here all three m's are not distinct. M equals to minus 1 by 2 has multiplicity 2. Now if in case of repeating values of m, we basically find our c using c raised n by n factorial into phi n plus 1 dash m. It is n times derivative plus c raised n minus 1 by n minus 1 factorial phi n minus 1 times derivative plus phi 1 of m equals to 0. But in our case n is basically equals to 2. So if we solve it, n is the formula is basically n minus 1 factorial n minus 1, and here it comes as n. So n minus 2, n minus 2, n minus 2 and n minus 1 and so on. So in our case n is basically equals to 3, so we'll be getting our formula as c square by 2 factorial into phi 3 double dash m plus c into phi 2 dash m plus phi 1 m is equals to 0. But my phi 3 is basically, phi 3m is 1 plus 3m minus 4m cube. Phi 3m is 1 plus 3m minus 4m cube. So if I take its derivative, I'll be getting 3 minus 12m square, and its double derivative will be basically equals to minus 24m. Likewise, my phi 2m is 0, so its derivative will also be 0. Now I can just substitute these values, and my phi 1m is basically minus 1 plus m, minus 1 plus m. So if I just substitute these values in stars, so I'll be getting c c square by 2 into minus 24m plus c into 0 plus minus 1 plus m equals to 0. So this basically gives me this 2 balances 24 as 12. So minus 12m into c square plus minus 1 plus m equals to 0. But we have two values of m, that is m equals to 1 and minus 1 by 2. So we'll solve it for c for different values of m. So when my m is 1, so my equation will become minus 12c square plus minus 1 plus 1 equals to 0. So from here I get c square equals to 0. That basically gives me c equals to 0. So my asymptote when my m is 1 is y equals to x plus c, that is 0. So that is y equals to x is asymptote. So likewise when my m is minus 1 by 2, so the equation will become minus 12 into minus 1 by 2 c square plus minus 1 by 2 equals to 0. So if I solve it, I'll be getting 6c square minus 3 by 2 equals to 0. So from here I got c square equals to 1 by 4. So that basically gives me c equals to plus minus 1 by 2. So my equation of asymptote when m is minus 1 by 2 is y equals to minus x by 2 minus 1 by 2 and y equals to minus x by 2 plus 1 by 2. So we have basically three asymptotes, that is y equals to x and y equals to minus x by 2 minus 1 by 2 and y equals to minus x by 2 plus 1 by 2. So let's move on to next question. So the next question says that find all the asymptotes of the given curve. So they have basically given us a curve and we're supposed to find all its asymptotes. So let's see. So the curve is basically x raised 4 minus y raised 4 plus 3x square plus y plus 3xy square plus xy equals to 0. You can easily observe that there is no asymptote to the curve parallel to x-axis and y-axis. So no asymptote to curve parallel to x-axis and y-axis. So let's find out phi. Highest degree is basically 4, so let's find out phi 4, phi 3, phi 2 and phi 1. So phi 4 m will be basically 1 minus m raised 4. Phi 3 m will be 3m plus 3m square. Phi 2 m will be m only and phi 1 m will be basically 0 because there is no term of degree 1 in the given curve. So I can find out value of m by equating phi 4m is equal to 0. So if I do so, I'll be getting m raised 4 equals to 1. So that basically gives me m square minus 1 into m square plus 1 equals to 0, and from there I got m equals to plus minus 1. We can ignore m square equals to minus 1 because that basically gives us imaginary value of m. So these are the value of plus minus 1. So my c will be basically, so in our case both values of m are distinct, that is 1 and minus 1. So this basically gives, now we can find the value of c. So my c will be basically minus of phi 3m divided by phi 4 dash m. So from here my c is basically minus of phi 3m is 3m plus 3m square and derivative of phi 4m is minus 4m cube. That basically gives me 3m plus 3m square divided by 4m cube, and this thing is equals to 3 plus 3m divided by 4m square. So when my m is equals to 1, my c is basically 6 by 4, that is 3 by 2, and when my m is equals to -1, my c is 0. So the asymptotes are y equals to x plus 3 by 2 and y equals to minus x plus 0, that is y equals to minus x only. So these are the two asymptotes to the curve. So let's move on to next question. So in the next question we are supposed to again find out the asymptotes of the curve. So the curve is x square plus x square y minus xy square minus y cube plus 2xy plus 2y square minus 3x plus y equals to 0. So you can observe that there is no asymptote parallel to x-axis and y-axis, and highest degree is 3. So phi 3m will be basically 1 plus m minus m square minus m cube. And phi 2m will be basically 2m plus 2m square, and phi 1m will be minus 3 plus m. So values of m will be that I'll get by equating phi 3m with 0. So if I do so, I'll be getting 1 plus m minus, it is m cube minus m square minus m cube equals to 0. So I can write it as 1 plus m minus m square into 1 plus m equals to 0. And if I solve it, I'll be getting 1 plus m into 1 minus m square equals to 0. So this basically gives me m as -1, -1 and 1. Now I can find out value of basically c. So my c will be satisfying this because we have two repeated value of m. So c will be c square by 2 square phi 3 double dash m plus c into phi 2 dash m plus phi 1 m equals to 0. So this basically gives me c square by 2. So my phi 3m is 1 plus m minus m square minus m cube. So derivative of phi 3 will be basically 1 minus 2m minus 3m square, and its double derivative will be minus 2 minus 6m. So phi 3 double dash m is minus 2 minus 6m plus c into phi 2m is basically equals to 2m plus 2m square, 2m plus 2m square, and if I take its derivative, I'll be getting 2 plus 4m. 2 plus 4m plus phi 1m, my phi 1 is minus 3 plus m equals to 0. Now I can solve this equation for different values of m. So this thing is equals to minus 2 minus 1 minus 3m plus c into 2 plus 4m plus minus 3 plus m equals to 0. So when my m is minus 1, so my c will be c square into minus 1 plus 3 plus c into 2 minus 4 plus minus 3 minus 1 equals to 0. So from here I got 2c square minus 2c minus 4 equals to 0. So this basically gives me c square minus c minus 2 equals to 0. So if I solve it for c, I can write it as c square minus 2c plus c minus 2 equals to 0. So from here I get c minus 2 into c plus 1 equals to 0. So my value of c is basically 2 minus 1. So my asymptotes are y equals to minus x plus 2 and y equals to minus x minus 1. Likewise, when my m is equals to plus 1, so the equation will be c square into minus 4 plus c into 6 minus 2 equals to 0. So if I solve it, I'll be getting minus 2c square plus 3c minus 1 equals to 0. So this is equals to 2c square minus 3 plus 1 equals to 0, and I can write it as 2c square minus 2c minus c plus 1 equals to 0, and I can take 2c as common, so I'll be getting c minus 1, and here I can take minus 1 as common. So this basically equals to c minus 1 into 2c minus 1 equals to 0. So from here I got my c as 1 and c is equals to 1 by 2. So asymptote when m is equals to 1 is y equals to x plus 1 and y equals to x plus 1 by 2. So we have 4 asymptotes to this curve, that is y equals to minus x plus 2 and y equals to minus x minus 1, and y equals to x plus 1 and y equals to x plus 1 by 2. So that's all. These are the only questions that are asked related to curve tracing and the asymptote thing. So thank you for watching.